Our next speaker is Terrell Russell of the IRAS Consortium, and his talk is entitled DAVID Initial Data Management Solution for UNC's Ready Avid Center.
Thank you, Corey. So this is a project at UNC that was funded a couple years ago and got roped in to make it real. So here we go. So the Ready AC project, I can read this to you, the Rapidly Emerging Antiviral Drug Development Initiative, AVID Center, also shortened even more to Ready AC, is an NIH-funded public-private partnership whose job was to develop antiviral drugs to combat things that we don't know about yet. So the Ready AC was one of 9 AVID centers that were funded by NIH and the NIAID. This particular center, one of the 9, received $65 million 2 years ago. This included 40 investigators across 23 research sites in 5 countries. And if you want to read more, here's a copy-pastable NIH award number. Thank you, NIH. Got a cool logo. And the mission is really about, well, I will just read because I don't want to get it wrong. So the response to the viral outbreaks has always been reactive, right? We don't know what to do until after we're in trouble. So vaccines and medications are developed after a virus shows up and we can figure out what it's doing and how to fix it or prevent it. Our mission is to instead proactively prepare for things that have not happened yet by developing antiviral drugs that are active against more than just the one virus at a time, right? So the theory here is that we can work against an entire family of viruses. So these are called broad spectrum antivirals, and they will help safeguard the well-being of communities worldwide against existing viruses and be more likely to be effective against future novel viruses that we've not yet seen across a family. And so the 4 families that were funded for this particular AVID center were coronaviruses, filoviruses, flaviviruses, and alphaviruses. And some of these are, scary words after that, right? These are the things that kill lots of people. So it's very important work, received a lot of money, and then they came to us to help figure out how to assess, design, and develop a data management solution for all of these people to share their information. And so over the course of, I guess that's what, 18 months on the screen there. First of all, we didn't know much about this to begin with, so we had to go talk to a lot of people and learn a bunch of words. We then developed a survey to figure out what these labs were doing today, because these were very functional labs. These were all very successful people. They're all world famous. They all have a lot of money, but they don't necessarily work together very often. The way that they communicate is strictly through publications, right? So, and that works, but if you want to work together, it's a trickier thing. So we asked a bunch of questions about the types of files, how often, the number of people in the loop, what they were doing, how many buttons they had to click, what kind of software they were using. And then we asked them to kind of brainstorm a bit about opportunities for automation and what do you think it would look like if you had some type of cross lab interaction? And, the eyebrows kind of move like, well, why would we want to do that? Talk about the security implications of all those answers. Drew some things on napkins and whiteboards in the fall of 22. Went back to the labs and went back to the technical people again and said, is this reasonable? Built some things for about a month and a half. Deployed for the first time in January of 2023 after about 6 months of learning a bunch of words. First quarter of evaluation, and then of course iterated on the reactions and the results that came back. Here's a bunch of questions we asked. I'm not going to read them all to you, but this is the scope of the survey that we both did in paper as well as through interviews. And you can imagine that what's going to be on the next slide is that they didn't have a lot of answers to a lot of these particular questions because these are not the things that they've spent their time doing. They've spent their time doing the chemistry, the biology, the science, right? The data is always just a means to an end. So are you familiar with FAIR? No. The answer is no, right? Some people had software that they were using. And there were just a bunch of small files, right? So what we found, this is not big data, right? This is not the genomics. This is not the imaging workflows. This is not the things that you guys are struggling with in HPC. This was thousands of files, maybe, over the course of a year, generated by tens of people, maybe tens of gigabytes. Like it's the data itself are just numbers in cells of a spreadsheet representing the number of things that somebody saw in a microscope looking at a petri dish, right? Some of that can be automated, maybe with some machine learning or image processing, but mostly it's people looking at a thing and saying 17 in a spreadsheet. Limited by the human scale of ingest, right? Mostly this was PDFs and Excel spreadsheets. There was some imaging file formats coming out of these labs, but really these were kind of pre-image wet labs. So it was mostly textual representation of what they saw in a wet lab. There was some electronic lab notebook. Some of them had electronic opinions about what to do, but mostly even those were still just pushing into Excel. And some of that was even manually calculated and copy pasted around. Right? Very little of it was automated. There was a lot of manual transcription from paper notebooks. And that was not just because this is a joke about the Dark Ages or rocks and sticks. This is because these are, and sometimes bio level 4 labs, and there can be no electronics in the room. So they have to write it on paper, and then that's the only thing that can leave the room. It's like, okay, that's new for me. Didn't know that. I'm also going to stay out of that building from now on. Their graphing, their kind of imagery was done in Excel. Sometimes, if they had a grad student who knew something that could program a little bit, they had a Jupyter notebook that would make a picture. Great. No shared naming conventions. Okay, we're going to start from the beginning, right? So data file names were consistent, usually for one person over time, just for sanity purposes. There might have been a little bit of metadata, but probably not. Sometimes multiple people in the same lab would use the same naming convention. Cool. But that's only because they had to work together, right? And as soon as a grad student left, the next one would not necessarily have to deal with the old person's naming convention. So they'd make up their own one. So we're learning. So the highest priority of this project was definitely, and this was almost universal, was about access and sharing because that was their mandate, right? They knew where their money was coming from. The project's data needed a home. It needed to be in one place. They had no central data repository. Hi, that was us. We didn't make one. No standardized data processing. Not because, again, they didn't want to do that, but because they were not consistent in what they were doing. We had chemists, we had biologists, we had all kinds of stuff, simulation people. The data wasn't even the same. Certainly no versioning. You can imagine no metadata of any consequence, right? What was also interesting is when we asked, what about your negative results? What about your failed attempts? Those don't make it into the paper notebooks. They don't make it into the Excel. They're certainly not making it in any graphs, right? And in addition to all of this, they were aware of the new NIH requirements that have come out in the last year or two, where public funded research must be publicly available, largely with no embargo time. I think the word immediately is used in the mandate. So they knew this, they knew they had to do it. This was funded, it had to follow the rules. So as you can tell, there was very little process to automate. Different instruments, different chemistry, different software. No, there's no blame here, nobody's fault. They just never been required to coordinate in this way. This was new. So we realized there were two projects, right? We had the people part, which is always hard and messy. People don't want to change what they do. They're not going to listen to me. I don't want to tell them what to do. This is a mutually beneficial relationship to not talk about how to change their science. But the software part, we had some opinions about. So really, there were only a few puzzles to solve. We thought we could handle it. The security part was new. We had to speak to lots of people to make that happen, so that slowed us down a bit. So the requirements turned out to be federated login for people who maybe had never talked to each other before. It had to be in a secure enclave. So that's the phrase at UNC for the computers in the safe place, right? For data where only certain people can see it. It really is just files, mostly spreadsheets. This is not a database coordination effort. They didn't each have databases of knowledge. This was just files. They had some annotation. That was what we were going to use to kind of keep track of stuff. We would like to automate. Obviously, they had to have some search. And there was no analysis that I was going to be building for them. There was no tooling that I had to incorporate. I just had to give it, I had to make access for download. They already had their analysis tools. They just needed a place for their data to live. So we drew on the whiteboard. We ended up with 4 VMs. I got 6 minutes. Great. This was a Docker Compose exercise. Originally, it was the REST API, moved to the HTTP API once that was real. CI logon was chosen for the identity mechanism. So I just had to have a list of email addresses. They had to go prove it. If it matched the email address, they got in. Turned out to be 2 applications. Well, 2 pieces that we built. There was the Angular application, which was what we called David. So it had an upload, an assay as a search, profile for people, and a profile for compounds. The iROD side turned out to have 4 recurring rules that were going to be put in the system to watch for new files, to deal with the compound profile mechanism, and then to handle assays, which were basically standard templates of action in a lab. So if they did have an SOP for a particular procedure, then that would be turned as an assay. And so when a new upload would be put in the system, they would affiliate it with a certain assay. And that way we had some consistency for how this data was generated. By February, we had the upload page. So we talked about schemas earlier. Here we are. So here's some standard stuff that they needed. Pick a family, pick a part of the group, add some stuff about the target and the virus and the family, things like that. And this would wrap it up, put it in a JSON file, and drop it in a place that iRODS could see. So not a lot of processing here, just bundling. That became, once it got chopped up in the server with the delay rule, this would be available for inspection and search and browse. I said search first. This is all available through jQuery, so nothing special. We didn't have to invent a lot here. It was mostly the mechanism of getting the standardized data into the system. The compound profile was interesting. This is, so a file that got uploaded could actually have information about a number of compounds. Makes sense, right? But later, what they're interested in is the cross-cutting view to see, well, show me all the information about one compound. Well, that information is across a number of otherwise disparate Excel files. This is not a database, right? So I can't just run SQL on it. So we had to write some rules and do some choppy bits to put the things back together and present it through here. So there was it processed a request to go do the searching and chopping. And then there was another delay that would remove it over a certain time because we didn't want these to accumulate in the system. These are generated data products, and they were only good for a while, a couple days, and then I would have them go away. If they needed them again, they could just regenerate because the regeneration wasn't complicated. It's just, they would be out of date after a while. And then this is the template information I talked about with the assays. So this was the front door for that. That was a year later. We didn't work out that we needed a standardized template to attach to uploads for the first 8 or 9 months. And then we realized they wanted some standardized procedures attached to how the files were generated. So generally, the process worked, right? The discovery process was tough. Prototyping was real. Finding time with people who are very important, who run labs, to come and look at a piece of software and have an opinion is extremely hard, especially if you want to have 2 of them in the room at the same time. We did interview 4 labs in person at UNC. The federated stuff worked. The login was complicated. That was a puzzle that we had never solved before, but attaching, REST API and a web app and a CI logon, and I'm not in charge of any of it, and I just have to trust the downstream values I get. That was new for us, but we got it working. They did upload 353 data files in a year, which doesn't sound like a big number, but that represents millions of dollars of research. The future is actually going to be different. So we spent the time on the process. We figured out what was hard. And having identified the requirements and the bench to data process for the first time, they then decided that our UI was insufficient for what they wanted, because they want to do a bunch of analysis also, and we were not going to be able to provide that time and effort and building the things out. So they went with an existing commercial vendor, which they didn't know about and had not found earlier, because they didn't know what they were looking for at the time. So once they found it, it was clear that that was the answer. That's what we would have liked to have built, but they already had 20 years of experience and it totally worked. So they chose to move to that for the upload and management of these things, now that they knew what they needed to do. Rensi continues to think this is interesting and is building a database level tool similar to the commercial product that we hope will be available for other projects at UNC without having to pay the commercial prices that this particular project that has money has decided to put into the commercial product. So wanted to thank the NIH as well as this next group. This was these are the virus people. And then the last group are the Rensi people who helped this become real. And I think that's it. Thank you.
Any questions? Got one.
So you performed the whole project start to end, and then in the end, so did they just move to the commercial product for just the GUI for everything?
Well, so the commercial product provides upload and metadata, and it already knows about the type of chemistry and compounds. They've got visualizers, they've got all kinds of things, right? Things that we wanted to build but didn't have time because we were only 2-3 people.
So then basically you made an incredibly useful POC for them and showed
this is correct.
How it should work. And then
that's right. This was the initial development of the thing. So the takeaway is that we solved the process for them. We understand the problem now. And then once they did, they said, oh, that's what we want.
Any other questions? All right. Oh, we got one in the back.
Wait. Yeah.
Hi, thank you. To follow up also on the commercial hop, well, one question you mentioned, they weren't familiar with the FAIR principles. Did some of them, through working on this, have a better understanding? And when they went to the commercial product, was there any discussion about if they can get their data back out of that commercial product?
Yeah, there's definitely, that was a big question as they went through this decision process at the end of 2020. What year are we in? 2023, they finished this. So they made the decision by January of this year to switch. And before that, we did a lot of digging and finding out that the API was there. You can get things out. And so there is a way to export certain things, as well as build other glue tools to communicate with other software that they are not necessarily incentivized to play well with themselves. So as long as you are paying them a little bit, you've got access to the API. And so you can build separate things with it. And they do have an exit plan if they need to do that. But for now, the plan is to pay for that through the life of this particular grant.
Thanks.
All right, we got one more question over here. Looks like we got two.
And then it's lunch.
And then we'll go to lunch.
So it's their fault.
Hi, well, thanks, Terrell, for doing an advertisement for the RSpace iRods integration. I think the point you made about the beginning where they were starting from, if you imagine that they were presented with RSpace plus iRods and the early start of the process in terms of organizing the data as they do now, but to do it properly in RSpace, and then a nice integration with iRods, wouldn't necessarily have convinced them at the end not to go with the kind of end of the process with the commercial vendor. But A, it would have been a much better solution, and B, it might have made them more likely to stick with that solution.
Yeah, it could be. I mean, they had very little preconceived notions. They just had a bunch of files.
One right in front of you, right here, Derek.
there. So you mentioned towards the end that you need to do identity federation between lots of different institutes. How did you come to select the tool that you did? Because we've also been facing these challenges, and there are quite a few, and of course, no one agrees. So.
Yes. Excellent question. So most of the researchers, all of the researchers on this grant were US based, so that helped a little bit. They were also almost all academic people. So they were at universities, they had academic logins. CI Logon has a quite extensive arrangement, a trust relationship with hundreds, thousands of organizations, and your organization is probably in their list. So you can go get a token, an OpenIDC token from CI Logon from your institution. You'll bounce to yours, do the dance, come back with a magic token, and then that token was presented to this application. And so if your email address was in the token and it was validated and it was in our list, you got in. Those were the requirements. It satisfied it. We didn't find anything else that did it without us having to learn and build things, which was good. So it was a pretty simple decision once we found it, but that was not, I didn't know about it. That was not obvious at the beginning.
Do you know if that's the only of those tools that was available in your institute, was already used by UNC?
It was already on our pre-approved list, which had to go to security people. So that was also a good, I forgot about that. Yes. So yeah, we already had, UNC was already in the list. So that made it easy.
Okay.